Hey, what's up, guys? Welcome to Unit 5, Day 1. In this lesson, we are going to be solving equations using algebra tiles, all right? And so if you will remember from previous units, whenever you have a rectangle, this represents a and x, all right? And then when you have a square, this represents a 1. And if you will remember, right, when it is a white or a green rectangle, it represents x. And then when it is red, that represents a negative x. And then the same for the square, right? A yellow square, or sometimes it could be a green, represents a positive 1, while a red represents a negative 1. All right. And so I'm going to give you just a few tips that is going to help you when it comes to solving equations throughout not just this lesson today, but really the entire unit. Okay. And so here are some tips that you want to keep in mind. So the goal of solving an equation is to find the value of the variable. Okay. So we want to find the value of the variable, the letter. And in order to do that, we must get the variable by itself, okay? And so that is what we're doing, okay? Sometimes you might hear it put in a big word. We are isolating the variable. We're getting it by itself in order to figure out what the value equals, okay? And so in order to do that, now we can move terms from one side of the equation to the other. But we must keep the equation balanced. In other words, whatever you do to one side of the equation, you must do to the other side of the equation. All right. And so these are just a few tips that are you're going to hear me say this 1,000 times over the course of the next unit. All right. Now, what we're going to be doing, okay, is we are going to be demonstrating this using our algebra tiles. I don't know about you, but I am a very visual person, okay? Just telling me how it works isn't enough. I oftentimes need to see it, okay? And so that's exactly what we're going to be doing today, okay? We could just do this using pencil and paper and numbers and X's, but today the whole purpose of today is being able to understand it by seeing it demonstrated, okay? So if you are not a visual person, that's okay. I still think today is going to help you understand and be able to visualize what's actually happening when we are solving equations, all right? And so because I don't have algebra tiles, and it would be hard for me to manipulate these tiles on the board, and there's some websites where I can do it, but it's a little harder to do. So what I'm going to do is I am going to turn it over to a friend who is going to model and demonstrate how to solve equations using algebra tiles. And so I need you to follow along in your guided notes sheet, and there's going to be a few spots in the video where you're going to need to pause and to draw the model down on your paper. And so even though you don't have actual algebra tiles, I don't have enough for everyone to have throughout the classroom, but you do need to draw a picture representation. You will also need colored pencils, namely a green one and a red one for your notes. All right, so there's just 2 examples that we're going to go through today, and then you're going to do one on your own. If you have any questions while you're watching, as always, please don't hesitate to raise your hand, and I will see you on the other side.
Hi everyone, Mrs. A here. Today we are solving equations using algebra tiles. So we're just going to do simple equations for today. And we're going to look at this with algebra tiles because it helps visualize the algebra for a lot of us so that it doesn't look too abstract. So we're going to start off again by talking about what our algebra tiles represent. So this tile will be +1. This tile, we don't know the length of it. We'll call that x since it's an unknown. And then this one, we're not using it today, but this one we usually call x squared because it's x times x. So that's our x squared. If we want these to be negative, we flip them over to the red side, and then they all become negative. So those are the tiles we're going to use. Let's look at our first question. We have an equation. An equation means that we have an equal sign with an expression on either side. That equal sign there needs to remain always in the middle of the equation. It doesn't move. And these terms on either side, we can move them from one side to the other by keeping both sides balanced. So let's see what I mean by that. Let's first get out the tiles that we have. On the left side of the equation, I have 2 positive x's, and I have 3 negative 1's, like this. So this is on my left side of the equation, and on the right side of the equation, I have positive 7 1's. There we are. Okay, like this. So the goal to solve an equation is always to get the value of the variable. We want to know what x is to make this equation true. In order to do that, we want to always get the x by itself. That means to isolate the variable. We want to get the x by itself on one side of the equation. In order to do that, we need to move things around. So right now, we have this negative 3 on this side of the equation, which is preventing the x's here to be by themselves. We want them to be alone on one side of the equal sign. So we want to move these over. We can't just move them over because then our equation is not balanced. But what I can do is add things to both sides, the equal amount to both sides, in order to get rid of those minus 3. So remember we talked about 0 pairs. A 0 pair is when we have a negative tile and a positive tile of the same size. So we have a negative 1 and a positive 1. They together make 0. So we want to use 0 pairs here. If I want to get rid of negative 3, I add positive 3 like this, because those will all become 0. They're all 0 pairs here. But if I add 3 to this side, the equation needs to remain balanced. I need to also add 3 to the other side. So I need to do this on this side too. I can't just add 3 on one side and not the other side, then my equation is no longer balanced. So I need to add it to both sides. This is great. Negative 3 and positive 3, those are all 0 pairs. They disappear. And now I'm left with 2x equals, what do I have all together here? Now we have 10, right? 2x equals 10. So that's good, but I still don't have what x equals. So you see how I have 2 x's? Let's break them up into 2 groups. Now I have a group with 1 x in it, and I have another group with 1 x in it. But again, we want to keep things equal. So if I divide this into 2 groups, I want to divide this side also into 2 groups. How can I do that? Well, they were 10, so I can do 5 and 5. And now you see that 1x equals 5, 1x equals 5. So here is our solution. X equals positive 5. Let's write that in. So this is how we manipulate the algebra tiles to get the x alone on one side with its value on the other side of the equal sign. It's kind of like playing around with a puzzle. Let's do the next one. So here we have now positive 1 equals negative x plus 6. So first we'll start by getting our equal sign in the middle here, and then we'll get out our algebra tiles that represent this equation. So we have 1 equals negative x, so that's a negative x there, and plus 6. Make them positive, and we have positive 6 there. Okay, so we need to get, again, the x to be isolated on one side of the equal sign all by itself. So we want just x by itself. Right now, here's the x. It's not by itself. These 6 1's, are in the way. So we want to get rid of the 6 1's. We can only get rid of them by adding the opposite so that we create 0 pairs. So I'm going to add on this side a negative 6 here. So if I have positive 6 and negative 6, these will all disappear because they're all 0. But I can't just add -6 on this side. I have to also add -6 on the other side because we need to keep the equation balanced. We can't just add something on one side. That changes the equation. So I'm going to put -6 on this side and keep things balanced. So there's my -6 on this side. Okay, that's good. Let's get rid of all the 0 pairs. So here we had 0 pair, 0 pair, 0 pair, 0 pair, and 0 pair. They're all gone, which is exactly what we wanted to happen. We wanted that x all by itself. That's great. On the left side, what do we have? Well, we have 1 0 pair there. Let's get rid of that one. Now we have this so far. So right now, we have -5 equals -x. But -x is not x. So this is the problem. We want the x to be positive. If we want the x to be positive, what do? Well, I can flip it over, and now it's positive. That's good, but we're dealing with an equation. An equation is the same on both sides. So if I flip this one over, what do I need to do on this side? I need to also flip it over to keep things balanced. So now I've flipped all these over, and here we have 1x equals 5. Here, we got the same answer as the last question. Now, this is just by coincidence. So we had 1x equals 5. We can write it like this because we can read equations in the opposite direction. X equals 5. If you don't like that, then just turn it around and do x equals 5. That's the same thing. It doesn't matter. We ended up with the same answer as our last question here, but that was just by coincidence. They're not related to each other in any way. So here we have our final answer, and that is how you solve simple equations using algebra tiles as a visual. Thanks for watching. Mrs. A Loves Math.
Hey, thank you so much, Mrs. A, for walking us through those examples. Hey, friends, in this lesson today, we have learned how to solve equations using algebra tiles.